In this video, I'm going to focus on disassembling and showing you everything that's inside the SplatRBall gearbox and how it works and how to take it apart and put it back together. If you want to see a video of how to disassemble the whole blaster, then check out some of my other videos where I show you how to disassemble and reassemble the blaster. This is just going to be about the gearbox. And now we're going to reassemble everything. So I'm going to take this contact, put it back in here, slide the O-ring back over, like that. Take this T-piece, put it back in here. Take the longer screw. Okay, now we're going to take this electrical contact that's passing through the gearbox housing and set it here on top. And find this plate with the medium-sized flathead screw. Screw that in there. Make sure that this contact is properly seated. If it's out of alignment, it may not work well anymore. Okay, now this is ready to be put back onto the gearbox housing. We have to slide this switch. Oops. We're going to slide the switch in here. Put the spring on top of the switch slider. Put the spring over this post. And then seat this whole switch assembly. I'm going to use this tiny little screw. Okay, now the trigger is going to go back in place, and we have to get this trigger over this torsion spring. So it's a little bit tricky here. I was able to just kind of hook it in here like this, and then get the trigger into the slot hole, but then I lost this other part over here. There we go. Then we have to get both pieces to fit into the holes on the opposite side of the gearbox, like this here. And this is a good time to kind of put this gearbox back together quickly to make sure that the trigger and switch is still working properly. So you can put this back in here like this, and then you can test to make sure that it's still working correctly. Looks good. As we reassemble this gearbox, we've wiped off a little bit of lube on the gears and things that slot, parts that slide and stuff. So this super lube grease, which is a Teflon-based grease, is what's recommended by the gel blaster community for a good grease for the gears and the O-rings and the air cylinder. So we're going to be applying this to the gears and the cylinder as we reassemble stuff. If I hold the nozzle here out towards the end of its stroke and test the compression. It is leaking air, and it's probably coming out the edge of the nozzle, because if I hold it all the way back, it's pretty firm. It's not leaking much air here. So it's losing air through this area in between the nozzle and the cylinder head. Everything else seems to be pretty well sealed with the stock O-ring. So it doesn't feel like it's losing much air at all with the stock O-ring. One method to keep some air from leaking out of here is to use a liberal amount of grease in there. The grease will have enough resistance that it won't allow airflow to flow out. So now if I hold it out a little bit and try the compression again, there's a lot stronger compression with that grease in there. It's good to apply a little bit of grease around the cylinder head. So there's actually a damper pad in here. There's this rubber pad which the piston head hits at the end of the stroke. We're going to add some more grease inside the cylinder. One of the most commonly talked about simple upgrades is to replace the stock O-ring on a blaster. People claim the stock O-rings are not usually very good. Although this one I saw that it was holding pressure just fine, but we're going to go ahead and replace that stock O-ring. So everyone talks about these magical green O-rings, and the green O-rings are a fluoropolymer O-ring that is mainly just available to buy from Asia, so it's difficult to get them here. You have to order them and it takes a long time to ship. What I found here as a substitute to the green O-ring are these Viton O-rings, which were very close in size. So the ideal size is supposedly a 20.2 ID by 2.4 by 25 OD. These are a 20.3 ID by 2.4, tiny bit bigger, 0.1 larger. Viton is a brand name for fluoroelastomer rubber. So these are probably the same material as the green O-rings, they're just not green. So we're going to try one of these to see how that works. I was able to purchase these from McMaster here in the US. The link is down in the description. If I compare this Viton O-ring to the stock O-ring, the Viton O-ring is larger in the overall diameter. It's also larger in the wall thickness. So let's see how this works. And here you'll have to pinch the O-ring in a little bit to get it to go in. Gonna make sure that it all goes in there snugly. Okay. These are the stock O-ring dimensions as far as the thickness. So the O-ring has a 2mm width, outer diameter, which is going to be difficult to measure. So the approximate outer diameter is close to 24mm. The space here in the slot in the cylinder head is only 2.45. The diameter of the cylinder head is about 23.25. This O-ring size, which was recommended by the gel blaster forums in Australia, is too wide because this is 2.4 millimeters and it needs to be quite a bit smaller than this width here, and it's too tight in there, so it's not allowing air to flow back in on the release, on the pullback stroke. So this size O-ring here that was recommended is not going to work because it won't allow air to flow back in. So for now I'm just going to have to stick with the regular O-ring and use that. The seal really seems good with the stock O-ring. So here we have all the parts of the piston cylinder. So we have this plunger tip, we have the cylinder head with the nozzle on it, we have the cylinder body, and then we have the piston head, and the O-ring. So this goes together like this. There's also an O-ring here that makes sure you add lubrication to everything when you reassemble. And then we've lubricated this area here to hold a better seal. and lubricate your O-ring and lubricate inside the cylinder before you reassemble. Okay, so that drops down into the gearbox body here. There's some alignment pins up here that these holes need to go into. The piston has some slots on the side and the guide in the gearbox housing to which that locates to. We can add a little bit of grease to that here. Now we're going to place this tappet back in here. So the tappet has to go over the end of the plunger, the nozzle that slides onto the nozzle here. I have to lift this up again, get it to all go together. Before putting the tappet back in, I should add some grease to that tappet slot. And here we have a spring that needs to go on this post here. The tappet has a slot in which it slides in too. So make sure that's working properly there. I'm going to add a little bit of grease here to the top of the tappet. As we put these gears back together, I'm going to put a little bit of grease on them. So we're going to start with the central spur gear. Grease on the shaft here on both sides. Make sure that the shims are in place. You see the metal shims are there. So make sure those are there. Put a little bit of grease on the gears. It's going to get spread around. We're going to take the spur gear and put it down in here in its position. Now we can do the sector gear, and so also apply some lubrication to the sector gear. Make sure that the shims are in place there. You get the shim on one side, shim on the other side. Now we're going to sneak the sector gear back in here. And get it into its bushing. There we go. The last gear is the bevel gear. So let's apply some grease onto that bevel gear. Make sure that the shims are in between the bearings and the bevel gear. And the bearings have the flange on the inside. So both sides should have their shims in place right here. Then we have to put the ratchet pawl back on. The ratchet pawl has the spring on the bottom like that. And this leg of the spring goes up against the wall inside here. And we're going to pull this ratchet pawl back. And then we're going to put the bevel gear into its hole in the gearbox. The ratchet pawl is going to want to push the bevel gear out of the way. So now at this point we need to get the other half of the gearbox cover back on and try to keep anything from jumping out. You're going to have to use a screwdriver in here to keep things in line. There we go. Focus on getting this bevel gear back in. Focus on getting all the gears into their bushings. Oops. Then I might need to push the tappet plate back a little bit. There we go. That's snapped in. And then get the trigger in place. There, trigger snapped in. Now the whole gearbox should come together. There we go. Yep. Everything's together. Now we need to put these screws back in to hold it in place. And remember that when you put the screws back in, always back up first until you hear a click like this. Hear that click, and then you can move forward. That click means that you are in the same thread path as previously, because these screws are plastic threading screws, so you don't want to be cross-threading too much into the plastic. Be careful not to over-tighten these screws. It will strip the plastic. And there's the last screw up here, small screw. And then you're going to slide this piece of sheet metal over the top here. And all the way back to where it was, right there. And then this clip that covers up the gears goes here. We successfully got the gearbox back together. Now I'm going to put the motor back on. So the motor fits like this, right here. All right, and I believe that we had the positive lead on this side of the motor, and the negative lead was on this side, on the bottom side. Now the gearbox is back together. You can put the spring back in. Although I don't recommend plugging the battery in before you actually have the gearbox set into the blaster, because if you do so, you have these electrical contacts are free here, and you could short something when you're pulling the trigger. So make sure these electrical contacts are not touching any metal or each other. In fact, you should wrap them in electrical tape while you're doing the testing. So here you can see if the selector slide is slid all the way forward where it's not touching the contacts, it doesn't do anything when you pull the trigger. Now, if you slide this back where it touches the contacts, but it doesn't hit the single shot selector yet, so it's just going to be in single shot mode. And it should work like this. If it doesn't work in single shot mode and you want single shot mode, then you're going to have to disassemble this and go back through and make sure that everything is correct before you put it back together. If you slide the selector switch all the way back, then you're going to be in auto mode. Now that your gearbox is all back together and it's functioning, it's time to put it back into the blaster and watch my other videos for instructions on how to properly do this. Especially now that we've kind of messed up the wiring, you're going to need to make sure that the wiring is tracking kind of in the same place. All this wiring used to be hot glued in place. It's going to be difficult to hot glue it back down now that you have grease on the outside and grease a little bit everywhere. So just make sure that these wires are in position and out of the way, and maybe you can use a little bit of hot glue to dab and get those wires back down before you put it back in. And here we have to place our electrical contacts in for the magazine. I did notice that what I at first thought was a hole at the bottom for allow water to pass through if water got in the blaster, I realized is now aligned with this hole for the motor, which is meant to have like a set screw in there to be able to adjust the motor position. So in a later video, we'll either replace this motor housing with a metal one that has a set screw, or maybe just even try to add a set screw to this plastic one and be able to adjust the motor position to get the perfect motor positioning. And there we go, the gearbox is back in place. Watch my other video to see how to reassemble the whole blaster.